Assalamualaikum warahmatullahi wabarakatuh. Today our lecture is about field effect transistor FET for SC analysis. Okay, now we go on to the next slide. These are the learning outcome. At the end of this chapter, student able to understand the effect of AC response in single stage FET amplifier, calculates amplifier parameters such as input impedance, output impedance, gain, and etc. So this is the FET small signal model. Transconductance. This symbol GM represent the transconductance of FET small signal. So the relationship of VGS to ID output is called transconductance. Transconductance is denoted by GM and is given by this formula. GM equals to delta ID over delta VGS. Delta means difference of ID divided by difference of VGS. That is from the difference for ID is from this point to this point, and difference of VGS is from this point to this point. You can subtract, then you will get the value. So this is the graph representing the FET small signal. We have ID on y-axis and VGS on the x-axis. The cutoff point for ID, we call it IDSS, while the cutoff of VGS, we call it as VP. So by mathematical definition of GM or transconductance is that GM equals to delta ID over delta VGS, and it is equal to GM equals to 2 multiplied by IDSS over modulus of VP and multiplied by 1 minus VGS over VP. This equation comes from the mathematical definition of GM, where it has been derived. So you can see that the derivation actually comes from 2 IDSS multiplied by 1 minus VGS over VP and multiplied by D over D VGS multiplied by 1 over VGS over VP. So from there you will get this formula. Okay, or GM is equal to D over D VGS multiplied by IDSS multiply 1 minus VGS over VP the power of 2. Okay, so from there, after you have derived the deviation, you will get this formula. Okay, so when VGS equals to 0, GMO, you can denote GM as GMO, so it is equal to 2 IDSS over VP. That is when you substitute VGS equals to 0, so you will get this equation only. So you know that GMO is 2 IDSS over VP. absolute of Vp. So by substitute this equation into this equation, you get Gm equals to Gmo multiplied by 1 minus VGS over Vp. So 1 minus VGS over Vp equals to square root of ID over IDSS. This equation actually comes from the equation of IDSS, where IDSS equal to ID equal to IDSS multiplied by 1 minus VGS over Vp to the power of 2. So when you move the power and also the current, you will get this equation. So by substitute this equation into the equation of Gm over here, you will get this equation. For your information, Gm is equals to Yfs and equals to Gfs. Yfs is the admittance, so it is actually 1 over. So now we continue our lecture. These are the difference of equation between Jfet, D MOSFET and also E MOSFET. Okay, you have this equation over here for Gm. For the FET input impedance, Zi is equal to infinity, and the output Zo is equals to Rd equals to 1 over Yos. Okay, where Rd equals to delta VDS over delta ID, that is when VGS constant. Yos is equal to the admittance equivalent circuit parameter listed on FET specification sheet. So this is the FET small signal AC equivalent circuit. The procedure of deriving the AC analysis start from the first one is to set all the DC source to 0 and replace them by a short circuit equivalent circuit. Replace all capacitor by a short circuit equivalent. That is for AC analysis, you have to replace all the capacitor by short circuit. And then remove all elements bypassed by the short circuit equivalent introduced by step 1 and step 2. So if you have capacitor connected to RS, means that if it is short circuit, so the current will bypass RS. That is example, only an example. So number 4 is redraw the circuit in a more convenient and logical form. For FET small signal AC equivalent circuit, this is the equivalent circuit for FET small signal. Student need to memorize this circuit in order to analyze in AC. So you have, this is the gate terminal, this is the source terminal, and this is the drain terminal. So if you convert this symbol to AC symbol, you will get this VGS, GM VGS. The current here is GM VGS, and also you have RD. You already, I already mentioned that RD is equals to 1 over YOS. That is your output. So here you can see Z out is coming from this side and Z in is coming from this side. Normally RG is the value of resistance for RG is very high. That is why Z in equals to infinity, approximately equal to infinity. So here are the symbol. Okay, now we go on to the analysis for common source bypass RS. The first one is to replace all capacitors with short circuit and set DC source to 0. So all DC source must be equal to 0. So here VDD must be equal to 0. VGG here must be equal to 0. So what happens if VDD and VGG equals to 0? This will be short circuit and it will connected to ground. Same as VDD, it will be connected to ground. So here you can see here the capacitor will be short circuit, CI, CO, and also VGG, and VDD will be grounded. So the circuit will be, the equivalent circuit will be like this one. Okay. Number 2, draw AC small signal equivalent circuit and substitute FET transistor model. So after you have redraw the circuit, then you have to change this symbol to the AC equivalent circuit, and then you will get this circuit, AC equivalent circuit. So as you can see here, you have RG, and then VGS, GM, VGS, RD, small RD, and RD over here. So here, if you want to find the input impedance is equal to the value of RG. Okay, so and then you can get the output impedance. First, you need to set V in to 0. So when this voltage input equals to 0, what will happen? VG will be equals to 0. So when this is equal to 0, this will be open circuit. Okay, dependent current source here will be open circuit. So the circuit will be like this. The remaining resistance is RD, small RD, and also RD. So you will have Z out equals to small RD parallel with RD. In order to find voltage gain, the formula is AV equals to V out over V in, and it is equal to minus GM VGS multiplied by RD parallel with RD. This is your Z out, and divided by VGS. This is your input. Okay, your input is actually this point over here, from positive to negative. Yeah? Okay, so the output here is actually the current I out here multiply with the output impedance. So this current is equals to minus GM VGS. The current that flow through RD is equals to minus GM VGS. So multiply by the output impedance. So the equation for voltage gain is equal to minus GM multiplied by RD parallel with RD. So this is an exercise. If you want to try, you can try. So that is all for today's lecture. I will continue the next lecture for the unbypassed circuit. Okay, so thank you very much.